Hello and welcome to this guide on how to write a specification. So I've designed this with GCSE Design and Technology in mind. However, this can be used for any course that you're doing or any project that you're working on. Okay, so let's jump straight in because I want this to be relatively snappy because I know I have a tendency to go on. So a specification, what it is by definition, is a list of requirements that a design must fulfill in order to be successful. So this is a really important part of any design project because once you've done your research and you're starting to think about your designs, it's really good to come up with a list of things that those designs need to be like. And this allows us to look back later on and to check that our designs do those things and allows us to sort of measure whether we're hitting all the points that we think we should. And why it's so nice is because it sits at the end of the research research section. It's really good for us to use to sort of bottle that research and to sort of clarify it as really simple, easy to sort of reference points, okay, if that makes sense. So let's move on from here. What we're going to be doing is we're going to be creating a table that looks like this. So if you want to create a table in advance and work alongside me, that's kind of how this video is going to be designed, with the idea being that you sort of do this as I do it. Then you can go ahead and create this now. So we're 4 columns wide by 8 rows tall, all right? Or if not, just hang fire, because what I'll do is I'll sort of talk about these columns individually and you can just work along with me and we can add these in. So you could start like this. So this is how I'm starting. I'm starting with just the 2 columns, all right? If you do want to do it how I did here, give it a pause, go and create this and then come back. Or if you're doing it this way, working along with me and going to add these columns in later on, then you can do the same thing. Go ahead and pause me now. Go and make this and then resume when you're ready, okay? So I'm starting with these 2 columns. And what we're going to do is we're going to talk about different headings that we need to think about, or different categories we need to think about, and then what exactly our design needs to do or be like under each of those headings, all right? So let's have a look at the headings I'm going to use. There we go. So I teach, as you know, if you're one of my students, I teach AQA Design and Technology, and these headings are ones that appear lots in their resources and things, and within specifications. So these are the headings that we're going to be using for this specification. Now, depending on what project you're doing or what exam board you're doing, you may have different headings that make sense. So things like size might be in here, weight might be in here. I'm just going to keep this to these 7 though for this explanation. And if you're one of my students following this, which you probably are, let's be honest, then these are the ones we're going to use. Okay, so form, function, user requirements, material requirements, performance requirements, production and cost, and sustainability. And what we'll do, let me just check what's on my next slide. Yeah, what I'm going to do now is go through each of these and what they mean. And what I think would be a really good idea for you to do at this point, if you've got this made, if not, pause me and go and make it. But as I go through these, I'm going to pose questions that you can use to help you write what you're going to write in these boxes, if that makes sense. So, form, for example, let's just do one. So form means the appearance of a product. So the appearance, the styling, the shape, the texture, the color schemes, and that kind of stuff, all right? So these are some questions that you can use to help you with what to write in there, all right? And what we're going to do, let me just jump back, is we're going to say for each of these, my design must, my design should, my design needs to be, right? We're going to create a set of comments that explain what our design needs to be like. All right, so let's have a look then at form. So this is what form means. These are the questions that can help you. So what should it look like? Should it be stylish and colourful? Should it be sleek? Should it be minimal? I don't know, up to you. What kind of theme should there be? What else can you say about how your product should look? And think about how it's going to attract the customer. So if I just skip through these other ones a second, what it's going to look like at the end is this. Here's an example that I've done. So in response to those questions, I've said my design will need to be modern in appearance and have a professional business colour scheme with subtle colours. The materials should look classy. All right. So I've specified here what my design needs to look like. Now, what I've been very careful to do is to say what my design needs to look like without limiting myself. So I haven't said what colours, and this is really important, especially when we get later on down here, is I haven't talked about exactly what colours it needs to use. I haven't said, for example, it needs to be blue and have brushed steel on it or anything like that, because anything I put here, what I'm effectively saying is these are the things my design needs to do in order to be successful. So if I go in here and start picking out colours, my design will need to be blue and silver, then what I'm saying is that all of my designs need to be blue and silver. Now, I could make a really professional looking design that meets this point here that isn't blue and silver. So I've just got to make sure I keep my options open, but at the same time, as the name specification suggests, I'm being specific about what my design needs to be like, okay? So I'm being specific without limiting myself, and that's something that's going to be really good to remember later on as we get into this. So what I'm going to do now, I'm going to go back to form, and I'm going to dwell on that slide for a minute so you can pause it, so you can do your own version of this if you're working alongside me, okay? So under appearance or form, I've said this. My design will need to be modern in appearance and have a professional business colour scheme with subtle colours. The materials should look classy. That is enough, all right? So let's go back. We're going to look at the second one now. We're going to look at the function. So let's rattle back through this. So form, if you want to pause on this while you go and write your own, then please do. Otherwise, I'm going to carry on to the second one. So function. What should your product be able to do? So function is the things that a design does, what it actually does. And for your product that you're designing, now obviously I'm keeping this kind of vague because you can use this video regardless of what project you're doing, so I'm not going to relate this to a specific project, but ask yourself, for what you're designing, what does it actually need to be able to do? Now, I think this is the most straightforward one to answer, because obviously you are designing a product that needs to do X, Y, and Z, and you've probably already defined that by writing a design brief. Some projects, for example, my Year 10 mouse project, we don't write a brief. So if you're using this for my Year 10 mouse project, then we won't have that. But even so, these things have been determined by the exam board. The exam board have given us the brief, all right? And it's going to be relatively straightforward, I think, for you to determine what it is your design has got to do. Now, you could do the overall functions. So if you're saying my product needs to do blah, 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 that's fine. But you might also want to dig down into some less obvious parts. There might be parts of your design you want to talk about. So the overall function must be this, but this part needs to do this, okay? Or it also needs to be able to do this. So there might be like primary functions you talk about, but there might also be secondary ones, okay? So if you're working on this, what I'd like you to do, if you're working alongside me, is pause me now and go and create a comment that says my design needs to be able to, or my design must, or my design should, and just explain what it is your design has to do. All right? Okay, so I'm going to move on. So hopefully you paused me and you have gone and done that. Let's have a look at the third one. So user requirements. So what does the user require the design to do or be like? So we're not thinking about, like, in the last one we were talking about function. We're not just thinking about what it does, but what has it got to be like in order to make the user experience good? So a keyword we would have talked about in my lessons is ergonomics. So ergonomics is about the physical relationship between a product and the user. Things like comfortable grips, or like when you put a lid on a pen and it goes click. It lets you know that you've done it. So anything that helps the user experience. So how will it be easy for them to use? What things will you need to think about when you create your design? So picture the person using the product, because it will really help. So you might think, oh, actually, yeah, if they're holding it in a certain way, or they're changing the function of the product, or they need to be able to remove a part of it, or something like that, think about what the user needs the product to be like and specify that in your specification. All right? So say, right, to be comfortable for the user, my product needs to, or to meet the needs of the user, I will need to ensure that my design has X, Y, or Z feature. Does that make sense? Hopefully it does. So pause me now and go and write a statement in your table. I'm not going to show you my example. I'm only going to show you my example for the form. But what I'm going to do now is I'm going to move on to the next one. So if you haven't already done so, pause me now and go and make your statement on that. Okay, the next one. Now, earlier on, I was talking about the need to be specific without being limiting. Now, where this becomes really important is when you're talking about your materials, because it's so easy to box yourself in here. The amount of times as a teacher I've seen people write, my design must be made from wood, or my design must be made from steel. This is a real problem because what it does is, like I said before, it limits all of your designs. You're effectively writing down here everything your design has to be like in order to be successful. And where we've got this information from is our research. All right, our research tells us what our design has got to be like. We're now explaining that in our specification. So it's really important you don't say things like it will be made from wood, it will be made from plastic, it will be made from stainless steel. Because, like I said, it boxes us in and limits us, and we have to meet these points later on. So instead of, let's have a look what I've written here. Instead of it will be made from wood, let's talk about what it is you want from your materials. So what properties are you looking for? Are you looking for strong materials? Are you looking for materials that are low cost? Are you looking for materials that are easy to cut and shape? Are you looking for moldable materials, attractive materials, materials with good impact resistance? So by defining what it is you want from the materials, you're still being specific. Remember, the specification is all about being specific. You're still doing that, but what you're not doing is limiting yourself. So some people say to me when I'm teaching this in lessons, they say, "Oh, am I not being really vague by saying it should be like this, it should be like that? By not saying what materials, isn't that like a bit of a cop-out?" And the answer is no, it's not, because you're being very specific about what materials you want or what type of properties you're looking for, but you haven't limited yourself to a particular material, because there might be different ones that allow us to still meet what you're saying and to meet your requirements, but it doesn't mean that you have to stick to all metals or all plastics, okay? So like we've been doing, you know it by now, pause me, go and write your statement. You could start it with something like, the materials for my design must be, and then you can state some of those things, or my design needs to incorporate materials that, or something like that, all right? So pause me now if you haven't, and I'm going to move on to the next one. Right, now, this I think is the most difficult of the 7 that we're talking about. This is performance requirements. Now, a lot of people get confused with this one, and they think that it's the same as function. It's very similar, but it's not the same. And the reason why is the function is all about exactly what your product does. Performance requirements is all about how well it does certain things, like almost like the measurable things to do with your design. So, for example, if you take a Ferrari versus, I don't know, a Nissan Micra, right? They both have a very similar function in that they drive a user or allow a user to drive in multiple directions down a road at varying speeds and whatever, right? They have very similar functions, but as I'm sure you can imagine, the performance is very, very different. So it's things like, if I was designing a car, for example, the performance requirements might be things like the horsepower. If I was designing an electric car, it might be the range or the charge time. If I was designing a torch, it might be the brightness of the light, the battery life. All right? But when you're designing something, you need to be careful, or when you're writing a specification point rather, you need to be careful that you're not saying the same thing as you did in function, because it is different. So it's about things you can measure. If I were to go and look up the specs for, I don't know, let's say the computer that I'm recording this video on now, the performance requirements for it would be things like the speed of the processor, the amount of RAM, whereas the function would be what it can do, if that makes sense. So we're thinking about things like power output, battery life, but also how long it should be able to last. So don't put like, my design needs to be able to last forever, because That is sometimes what people write, and it's not realistic. So we need to come up with maybe a realistic time frame. And you could also mention things like replaceable parts if you wanted to say like how it was going to last forever. But remember, I'm probably not expecting you to write any more than this amount of writing on my screen right now for this, so you just need to be careful that you're not writing an essay for this one. So you could start by saying something about the performance, maybe about battery life, and then move into a second comment probably about how long the product should last. Now, the one thing I've sort of not mentioned here is the need for you to just state these things at this point. You don't need to go into detailed explanations about why it's important yet, because we're going to do a whole column on that in a minute. Right, let's move on then. So if you've not done so already, pause me, go and create your statement, and we will move on to production cost. So again, this is one of those ones where you're going to need like 2 comments, because on the last one we talked about something to do with performance, but also to do with like the length of time it should last. Now on this one, we're talking about how is it going to be produced or manufactured, and anything to do with cost. So I've bundled these together. I think when you look in the AQA specification, these are separate points, but we're going to do them together. So we're going to talk about how is it going to be made. So how will it need to be made and on what scale? So we're talking about production scales here. And we're talking about either one-off production, batch production, or mass production. So one-off production obviously is one. A batch might be if it's a specialist product that you're not going to be making that many of, or if it's quite a big product that you cannot produce many of. So I'm thinking maybe like houses or performance cars might be batch production, where you're producing a number at once, maybe between 25 and let's say 1,000, depending on the product. But you're not producing them in the millions, and you're not producing one at a time. You're producing them in groups, using things like templates, using things like jigs and hand tools and things to speed up production. All right, and obviously mass production is all about producing things in their thousands, maybe their millions, about using high-speed machinery and like forming techniques in order to be able to produce those. So you've got to think about the product you're designing. Which one of those 3 is likely to be the most appropriate? So you could say in your comment for this one, my design will need to be suitable for, let's say, batch production. But then also go on to state what kind of processes would need to be would be most suitable for it. So, for example, let's say if you were designing a computer mouse, which I know that one group of my students are at the moment, you would say mass production using processes like injection molding. All right. And the second thing we'll need to talk about then is cost. So how expensive should the design be? Don't say, like it says here, don't say it should be £10, but say whether your design will be like a premium or a budget option, or be, should we say, price competitive with other options on the market. But also, actually, you could tie these 2 together. So rather than stating about what scale it's going to be made of and mentioning a process that it would use or could use, if you use the word could, it doesn't limit us to only using that process later on. So that's a good idea. But you could also then tie this into this. So you could go on to say, let's say you said here, for example, your product needs to be produced using mass production techniques such as injection molding. You could then say this would enable the design to be sold at a lower price point in order to make it more competitive with other products on the market. All right. So go and do that now. Pause me. Go and write a statement that says what scale you're designing for. Suggest the type of processes that could be used. And maybe as a second point then, talk about the price point you're aiming for. All right. Let's move on. The last one coming now. Sustainability, the environment. We're talking about how well this design, or how damaging this design will be for the environment, or needs to be. So, should it be good for the environment? Yeah, probably. In this sort of day and age, we We don't tend to deliberately design products that are bad for the environment. That would be a no-no. So yes, it will need to be good for the environment. It will need to, or if not necessarily good for the environment, it needs to be sort of not damaging to the environment. What things might you need to think about in terms of this? What sort of materials could you consider that might be better for the environment? So the things I'm thinking of here, there's three main areas that you can talk about here. You can talk about, actually there's more, you can talk about using recycled materials. So that might be something you specify here, that my design needs to be able to incorporate materials that are recyclable or recycled even. So it's about whether the product can be recycled at the end of its life, or are you building it from materials that are recycled from something else? So those are two things you could talk about. But also, is there anything you can talk about in terms of product reuse? So could you say that, for example, your design needs to have replaceable parts in order to extend its life, therefore reducing the need to buy a new one, which makes it better for the environment? Because obviously the more you make, the more you buy, the more materials we're using, and the worse for the environment your product is. Another thing, what about power usage? You could talk about the amount of power that your design uses and how efficient it needs to be, because obviously the more power it uses, the more wasteful it is. Obviously, the worse for the environment that is, because we have to burn fossil fuels, etc., and generate the power in order to be able to run this device. So that's what you need to think about there. Now, I did have something else I was going to say, but I can't remember. Oh yeah, so features as well. When we're talking about the efficiency of the product and the amount of power it uses, etc., you could talk about features that the design will need to have that will help you to limit the power usage. So you could talk about it must have like an automatic cutoff or something like that, or a sleep mode, or it depends what you're designing really. But think about, are there features that you could specify here that your design will need to have in order to assist with this point here. Right then, so what I'm hoping you've done by now, if you've been following this through, I obviously did my first example up here to do with the appearance and the form. What I'm hoping you've got is a statement in each of these boxes that links to each of these here, right? If you haven't, if you've missed any or whatever, just go back through this video and you'll be able to find the different spiels I've done on each of these, okay? And make sure that we've got a statement under each of these. So if you remember, they should all start with something like, my design will need to, my design should, my product must, it is important for my design to. All right, these are all comments where you're saying what your design needs to do or be like. All right, so hopefully you've finished that by now. The second thing then, and actually if you're writing a basic specification, let's say you're doing this for a project and there isn't a lot of time to do this, you could stop here theoretically. All right, you've said what it needs to do, and we've got a list that we can measure against later on. However, for GCSE, what we need to do is we need to go into a lot more detail than this in your coursework, your NEA. We need to start talking about why this is important. All right, so the word justification, it means to justify this comment. It means to say, basically, why is this important? And another way to look at it is by saying, what if your design didn't do this? So this is something, the second question on here, this is something I always say to students if they're stuck on what to put in this box. So they might write some of these and say, oh yeah, it's important to do this because, it's important to do this because, it's important to do this because. But if they get stuck on any, well, I flip the question around and say, well, okay, well, what if it didn't do this? So whatever it is I'm designing here, I've said that it needs to be modern in appearance and have a professional business colour scheme with subtle colours. The materials should look classy. All right, well, what if my design wasn't classy? What if the colours weren't subtle? What if they were like really in your face? What if they didn't look very businessy? Well, the customer I'm trying to sell it to, which is business people in this case, wouldn't want to buy the product. It wouldn't be suitable in appearance. It wouldn't fit in with other products they own. It's unlikely to sell. All right. So this is what we're going to do next. Let me show you what I've written. So I've put, it is important for my design to appeal to business people, so the colours will need to be appropriate. If the materials look cheap, then they are unlikely to want the product. All right. So in this second bit here, I've added to this first bit by saying, well, basically, if it doesn't do this, so if the materials look cheap, then they're not going to want the product. So I've kind of used this little tip here in this bit here, all right? So what you will need to do now, let me just check where I am in my own presentation. Oh, yeah, okay. So what you guys will need to do now, if you're following along with me, is take each of the things you've written in here, one by one, and say to yourself, right, well, why is it important for my design to have these functions? Why is it important for my design to meet these needs of the user? Why is it important that my materials are, I don't know, depending on what you've written, maybe strong, durable, attractive? So go through each one and just state why is it important for it to do those. And like I'm saying, if you are stuck, or even if you're not actually, this is a really good thing to look at as well. The question of, well, what if it doesn't do that? So don't feel like you have to just say it's important because it's important because. You can start it with, if my design didn't do this, then blah, blah, blah. All right. So pause me now. Go and do that. Go and explain why these things are important. And we'll look at the third bit together in a second. All right, so here we are. This is the last part of this. And I think this is probably the hardest part because you might be saying the same thing again and again. I think the first part was reasonably straightforward. The second part, hopefully, should have been quite easy for you. If you've said why your design needs to be a certain way, then hopefully you understand why you've said that. But this bit, we need to think a little bit about how we can prove it. So it's all very well, like if you go out into the world of business and design and you create a product and you've said, yeah, my product needs to be like this, it needs to do this, it needs to look this way, it needs to perform this way. Obviously, we're going to use this specification later on to judge our designs against and also to guide what we're doing in our designs. So it's really important that there's some way for us to check at the end that our designs actually do what we said. Because if they don't, then they're not successful. If I say my design needs to be professional and have a business color scheme, well, if in my mind a business color scheme is pink and yellow, and I go and design a load of products that are pink and yellow with flashing lights on them, really, that's probably not going to meet the needs of business people. In my mind, it might. I might be deluded. I might be like, yeah, this is going to be great for business. But there needs to be some way that I can check that I've met this point when I've finished my design. All right, so let's have a look. I'm going to show you what I've written for my one. So I'm just sticking with form as the example again. So I've said here, to test that my product achieves this, I could ask a number of business people what they think of the design by doing a survey. The results will tell me if the design meets this criteria. So I've said what I'm going to do, or what I could do, in order to find out if my design is suitable for business people in terms of its appearance. So when you go on to these other ones, how could you test that your design does what you said it should do under the function? How could you test that your design meets the needs of the user? Let's say, for example, you've said here that it needs to be comfortable to hold, whatever it is you're designing, or easy to use. Well, how can you check that it is? It's all right having our own opinion, but how can we check? How am I going to be able to check that my materials are, let's say, durable? How am I going to be able to check, for example, that the battery life is a certain length? How am I going to be able to check whether my design is suitable for a certain process? And how am I going to be able to check that my design is sustainable? All right, so let's have a look at the types of things you could put in here. Before you go off and have a go at these, let's have a look at the types of things that you'll need to resort to when you're talking about how you're going to check. So I've got 4 main ones for you that you can use. Obviously, if you've got a great idea about something else you can do, then great, you can do that. But when we're doing this, there's 4 main ones I've got in my head, certainly. And they are, like I talked about in my example, a customer survey, or you could do a focus group interview or an interview with an individual client in order to find out feedback from them. You could do physical tests. So, for example, when you're talking about the materials, you can talk about doing drop tests on the materials to make sure that they are able to withstand forces that they're likely to encounter. Or you could say you could do stress tests in a lab to make sure that they have the desired properties. All right. You could even combine the two here, the physical tests and the customer survey. So if I go back, under functions, if you said it's got to do X, Y, and Z, yeah, okay, you could get a user to use the product, and you could film a user using it to see if it works in the way that's intended. But when it comes to things like user requirements, you could, hang on. When you're doing user requirements, you could have a focus group perform physical tests on your product to make sure that it works as intended and is, let's say, comfortable to use, or is easy and intuitive to navigate the features of, or whatever it is you've said it's got to be like. Okay, so you can mix these up. All right. Product comparison. So if anywhere you're talking about your product and how it needs to perform or what it needs to be like in relation to other products on the market, you can then take your design when you've got a prototype and compare it against others on the market. So, for example, let's have a look here. If you said that, let's say production cost, under the cost part, if you've said my design needs to cost between £20 and £30 and target the upper end of the market or the more prestigious end of the market, you could say that to check if it does that, that you will take a similar product, or you'll investigate similar products that are aimed at the same area of the market and compare the price to see if yours is competitive. All right. And final design analysis. Now, this one really, if I'm being honest, this one is a little bit of a cop-out. So this one's the one I suppose you'll use if you're stuck. If you're stuck for anything else to write. Let's have a look at where you might use this. So back in this table here, if I'm talking about production, right? If I've said my design must be suitable for batch production, produce with numbers between, let's say, 250 and 500 in a batch, right? If I've said that, well, how am I going to prove that it's suitable? Well, I could say I could do a review of the final product, the materials and processes that will be used to produce the design, and check if they are suitable for mass production. Now, you might think of something better you can say here, but sometimes the only way to test whether it does something would be to go back and just visibly check the details of the design, to review the processes, the materials in question to check it. Now, obviously, for something like material requirements, well, we can talk about better things than that. We can physically go and test these things. But certainly under production cost and probably under sustainability, it might be a case of going back and reviewing the details of the final design and the components used and the materials used and the processes used to check that, let's say, for example, the materials are recyclable, or that they can be recycled at the end of life, or under production, like I was saying, that that they are suitable for mass production or batch production or whatever it is. All right. So as a quick sort of summary for here, what I'd say is function. Well, you can do some sort of physical testing. Maybe you can get your clients to test it or your possible users to test it. User requirements, again, you're going to want user physical feedback, maybe, or visual feedback on it to check that your design meets their needs. If you've said it's comfortable to use, etc., you're going to be wanting to talk about that there. Material requirements, chances are this is going to be about physically testing the materials. So you're going to probably want to talk about drop tests, stress tests. If you talked about things about appearance in terms of the materials, then it might be visual checks, or it might be user feedback again. Performance requirements, you could say that depending on what it is you've said about your design, let's say if it's battery life, you could say put the design under repeated usage tests to make sure that it performs as expected over time, that it lasts as long as it should, that the battery lasts as long as it should. If it's something that emits light, you could say you can use like a light sensor to check if it's like I said earlier, an example here, if it was a torch, you could do a test with a light sensor to ensure that it's producing enough light, or you could use a meter to check that it's releasing enough power. So something you can use to measure how well your design performs, but also how long it performs for, if you've said that as well in your statement. All right. And a good example, I think, is if you go to IKEA, sometimes you'll see, like in a glass box, they'll have a chair that's being sort of repeatedly tested by sort of hydraulic like a hydraulic ram constantly sitting down on it effectively again and again and again. There's like a ram with like a moulding of a butt that just keeps sitting down on this chair again and again and again and again to test basically how long this design will last for, how many times you can sit down and stand up off of it. All right. So you could say something like that in here. If you design, let's say, a computer mouse, you could set up a rig that presses the buttons repeatedly to check how many clicks they're good for. And this is what they do very often with things like keyboard switches or buttons in a mouse, is they will physically, in a lab, repeatedly test those buttons again and again and again and again to see like how long they last and when they will fail. All right, production and cost. So we're talking here, I won't dwell on this one because I've already spoke about this one at length, but we're talking about under production and cost, how you can check your design is suitable for the production scale. So it's going to be reviewing the design, inspecting the individual components, and the processes you've decided that would be used. It might be just checking that the components of the design are suitable for the production techniques that you have stated. All right. So if it's an injection molded part, for example, there needs to be no undercuts, which means that you can get the design out of the mold. All right. So things like that. Cost, you could review against other designs on the market, like we said, to check that yours is in line with where you think it is in the market. Sustainability. So on this one, you could, for example, make a test model and check whether it can be taken apart easily for recycling. You could do a design review where you check all the parts of your design before production to see if they are all using potentially recyclable materials or recycled materials, just to make sure that every element of the design is as recyclable or recycled as possible. So just something you can say basically to check how your design meets this part here. All right. So that is it. So what I would suggest is if you're somebody who's watched this straight through and hasn't paused us as we've been going along, maybe go back now. Maybe go and pause yourself wherever you want to for any of these bits. But I think that pretty much covers it. So I'm going to wrap this up quickly because, like I said, I wanted to be relatively brief, and I'm aware that I probably haven't been. I've probably talked for quite a while, as I tend to. But this will be a really good guide for basically any specification you're writing in design technology or engineering, okay? And like I say, this is aimed at my students in my class, but obviously if you're using this for another project or whatever, the same things still apply, okay? The same columns will be useful, and the same level of detail. And even if there are other headings you could use here, these are a good place to start from. You could add others in if you wanted to, but, like I say, this is probably enough, all right? So that is it.